welcome to another episode of Modular in a Week. We are on part 3 of building our Baby8 sequencer, and in this episode I'll add some controls to the sequencer. So start, stop, step forward, hold, and reset input, stuff like that. So I'll show you how to do that. I'd like to say thank you to my Patreons before doing that, and who support me over on Patreon, of course, and support my work on this modular here and all the other stuff that I do behind the camera, which they sometimes get a glimpse of when I have enough time to set up camera and do all that. So if you feel that you would like to support me, please head over to Patreon and check out some of the stuff there. With that, let's go and look at the schematics, how to connect these new controls to our already built circuit, and we can listen what we can do with it. Hello, it's me again. It's been over 2 weeks since I did that last recording that you just heard. I tend to do that. I tend to record this first session before I do what I say I'm going to do, because that's correct in the time frame. That doesn't always work out well, and then I sometimes re-record them. Now I re-record it, but I keep the other one. And in between these, I had a video before this one where I complained that I couldn't get the AND circuit to work, and I was going to switch to a 4066. I did that, and I got other problems there. Turns out that it's not the chips that's the problem, it is me and my electronic skills that is the problem. I am in many aspects a newbie also in this, and I'm taking this process of doing the modular as a way of learning. So what I've learned is that electricity always wants to take the easiest route. This is something I have known a long time, and probably all of you know that as well, so I will explain this better, but I'm back with the 4081 and circuit. It will work with a 4066 instead as well. I can explain that shortly, how you can do the same functionality with that, because that's good. If you don't have a 4081, you can have a 4066 instead. There are other interesting stuff we're going to do with the 4066, so we'll get into that one as well. So yeah, just so you know, all this was just me not getting the buttons to debounce in the correct way, which is really important in these circuits, to not get double and triple presses when you press just once, and to get, when you press, that you have a high voltage and not that it goes straight down to ground, for example, or goes into another input which you didn't have a resistor to. I will show this right now. Alright, first let's get into the debouncing of switches. I've covered this in previous videos where I did a rock solid data encoder with debounce switches using 4106, I believe. We're not going to do that today, and the thing is, most switches are debounced for presses where the press goes to ground. But I did find this article on All About Circuits, which I'm going to link to in the description. This is not how you do it, and this shows you everything you need to know about debounced switches and why you get those extra or multiple presses of a switch. So down here you actually have a circuit both for clock pin held low pulse high and clock pin held high pulse low. So these are the perfect circuits for both situations if you want to have the switch to go high or you want it to go low. So take a copy of this image here and have that among your very useful circuits to have around. With that said, we go into ECEDA and look at the schematics that we did from the last time. So we're keeping the 4081 as I said, and out here I've prepared the circuit we just saw on that on allaboutscircuits.com with the button connected to VCC. So this will be the step and hold button, and this toggle switch over here, the one that toggles between two legs, is going to be the run stop. So let's begin with the run stop. That is really simple. Because we have an AND circuit, what we do is we connect the middle pin to one of the AND inputs, and the on pin of the switch connected to V voltage plus. So when we get a pulse from the clock, that will and this one is set to on, so we get an AND because both the clock and this one is connected to voltage or 1, so we get a logic 1. And when the clock goes low, it goes low, and that way we get the clock signal. Now when this one is low, the AND will never be AND because this one is low. It will only be the clock going in, so there will be nothing coming out of from the gate. So let's put this in place. Now it would be good to debounce this switch as well. And then we need the clock signal. So we have the clock input here, and we take it from there. And I'm well aware I'm outside of the sheet right now. There's a lot of stuff going on in this schematics. Another thing you could add, because the switch I'm using, the K85851D-L1, is a dual switch, so it actually has two switches inside of it. So we could add an LED. So we could add an LED here for running. So an LED that shows that that this module is running. And an LED circuit for running should look something like this. The 1K is probably not correct. I don't know the value. I have to check what value to put there. All right, so the step hold then. And this one we add as just as a buffer into this one, so we add it to both pin 8 and 9, and out of this one is also a clock signal. So now we need to remove the clock signal here, so it is actually not going back in there. Do like this. So the clock input over here instead. now both these signals from both these gates should go out in here. I need a bit of room there, and from this one like so. So the clock input goes into the 4081 and also these two switches and mixes the signal and going out to the clock. Now here comes one of the problems I had in the first iteration of this 4081 circuit. I just couldn't get these two buttons to work together. And that's because, as I said before, the electrical signals always wants to take the easiest way, and if there's two ways that are just as easy, I guess they split the signal between the two. So solving this is, as when you know how to solve it, it is quite easy. So you add two resistors on these, and I did them 10K, and that worked just fine. So with resistors on these both outputs from the 4081 going into the clock of everything, the signal goes the correct way, and these two signals don't mess with each other, and we get both step, hold, and run functions. So I'll put these components in place and I'll show you what we can do with this. Alright, so we have it connected here, and we have a few other sounds going around here. So here's a sequence going. Let's turn that off for now. So it's not running. We are on step 1, and if we press the step hold key, we can step through all the switches, and if we add a reset on pin 3, we only go between these two, so that works as well. And now we go through them all, and if we turn on the run switch, it runs, and again the reset works, and now this one is a hold. So and now it's a step. So here we have all the controls that we want. Alright, so this last part of the Baby8 has been a ride, and I have hopefully learned a lot, and hopefully you have too. by watching my mistakes. So again, this would have been so much easier with an Arduino, but again, I am staying away from that a while longer, just to see what other options there is in the analog or old school world. In the next episode, I found a really cool tap sequencer that I'm going to show you how to build. And until next time, take care. Subscribe. Do all that thingy and the bell button and all that. And then I'll see you in the next episode. Bye.